Hi folks, we're going to take a look at page 59, number 17C. So they're asking us to determine the value of the limit if it exists. So the first thing I notice here is that the denominator is approaching 0. So if the numerator isn't also approaching 0, we know the limit's not going to exist. Otherwise, we're going to have to do some work to see if it does. So let's see what happens. The numerator approaches, well, this approaches 0 plus 5, so root 5 minus. This also approaches root 5 as x approaches 0. So the denominator and the numerator both approach 0, which means the only thing we can say is that the limit might exist. All right, so we're going to have to do some algebra here, and hopefully we'll get something that reduces with that x in the denominator. Since I've got these variables of x in the numerator that are stuck inside these square roots, I'm going to multiply numerator and denominator by the conjugate in order to get them out. So hopefully I can do a little more algebra after that. All right, so I'm going to multiply numerator by root x plus 5 plus root 5 minus x. And then, of course, in order to not change the expression, I also have to divide by root x plus 5 plus root 5 minus x. All right, and this was going to set up a difference of squares in the numerator. So again, the middle terms in this expansion are going to cancel out. So I'm just left with root x plus 5 times root x plus 5, which of course is just x plus 5. And then here minus the square of root 5 minus x, which is just going to be 5 minus x. Here, don't forget to put brackets. I want to make sure we don't make any silly errors when distributing. So in the denominator, I'm still left with x times root x plus 5 plus root 5 minus x. All right. So let's simplify the numerator, see what happens. So here I've got x plus x, so I've got 2x. And then here I've got 5 minus 5. Okay, that cancels out. So it looks like this is going to work out in the end. Okay, because I've got this x in the denominator, which is now going to reduce with the one in the numerator. Okay, so root x plus 5 plus 5 minus x. And so these reduce. And now I'm left with a limit that I can go ahead and evaluate. All right, so the numerator is just a constant. It approaches 2, and the denominator is going to approach, well, here as x approaches 0, this is going to approach 5, so that's root 5. And then here, this one is also going to approach 5 in the square root, so another root 5. So that's going to be 2 over 2 root 5, and reduce the 2's, and I just end up with 1 over root 5. All right, so in the end, this limit did exist. Notice how before I even started, once I saw that the denominator approached 0, I checked that the numerator did also, because if it didn't, we could say right off the bat that the limit doesn't exist. Once I realized there was a possibility, again, anytime I see square roots with variables in them, I should be thinking of possibly multiplying by the conjugate in order to release these variables from the square root. And from there, I was able to proceed and determine the value of the limit. Okay, that's it for this one.